take some time and talk about temperature units and how you can actually get tripped up on them if you're not careful. So this was a summary of where we finished in a previous problem. That was the problem in changing volume and temperature. We used Charles's law, which says that volume and temperature are directly proportional to each other. And when working the problem, we changed from Celsius to Kelvin, and we put Kelvin temperatures into the problem. Now your check when you're done is what's happening to volume when you change temperature. So with this relationship, since they're both directly proportional to each other, if temperature goes up, then volume needs to go up. If temperature goes down, then the volume should go down. So if you look at our temperature T1 to T2, it's going up, which means the volume needs to go up. And it did. It went from 3.5 liters to 3.77 liters. All I did was moved some information up and took out the text, and then just moved some things into the background. Now, all term long, we push with you dimensional analysis. Use your units and calculations. They'll help you. And I'm not saying they won't help you with this one. You still have to use your units. But something interesting happens. The bottom one, that's where I use Celsius, unless I forget to convert to Kelvin. So I have 46 degrees Celsius over 23 degrees Celsius, and then my final answer is 7.00 liters. And then I do my unit check, and just focusing on the temperature units, and the degrees Celsius units appear to cancel. And so look, the units cancel. The temperature goes up, the volume goes up. It goes from 3.5 liters to 7 liters. It appears to pass the checks. The problem with this is that Celsius to Kelvin is an additive offset, and that's what messes you up. The milliliter to liter, that's a multiplicative offset. You know, if you're going between pressure units, atmosphere, bar, or torr, or pascals, those are all multiplicative offsets. Temperature is additive. So you have to get it straight that temperature must be in Kelvin when you work these problems. You may not catch the mistake right away if you use Celsius.